Welcome back, students. Today, we will be learning about one of the fundamental concepts of algebra, linear equations. Make sure to check out our short video posted on dependent and independent variables if this section is new for you. Getting back into it, linear equations are used to represent a relationship between two variables with a degree of 1, which means that if we sketch the equation on a pair of axes, the sketch will just be a straight line. The general form of a linear equation is y equals to mx plus c. This form is also called the slope-intercept form. Here, y is the dependent variable, x is the independent variable, and m and c are constant values. M represents the slope of the equation, which refers to the steepness of the graph, and can be calculated by finding the change in y values divided by the change in x values, and c can be found by finding where the line crosses the y-axis. Since the slope-intercept form clearly provides us the values for the slope and the y-intercept, it is most useful when we are given the graph and need to find the equation, or we have the equation and need to graph it. Another advantage of it is that it is easier to find values for y given a value of x. The second way to represent a linear equation is by using the point-slope form, which is y minus y1 equal to m times x minus x1, where y is the dependent variable, x is the independent variable, m is the slope of the line, and x1, y1 is a point on the graph. The point-slope form is ideal when a specific point and the slope of the line are given, and we need to find the equation, or when we are given specific data points. This chapter is best understood with examples, so let's get right into practice. For the first example, let's make a data table and then plot it. So we have the equation y equals 5x minus 3. We need to find values of y when x equals to negative 2, 0, and 5, and find the values of x when y equals 3 and negative 10. And let's graph it as well at the end. To solve this question, we will plug in the given values into the equation one by one and find the corresponding value for the other variable. First, we plug in x equals negative 2. That gives us 5 times negative 2 minus 3, which is negative 13. Then we plug in x equals 0, which gives us minus 3. Next, we input x equals 5, and that gives 5 times 5 minus 3, which simplifies to 22. Now we plug in values of y to find the corresponding values of x. So plugging in y equals 3, we get 3 equals to 5x minus 3. The 3 on the right side goes and adds on the left, becoming 3 plus 3 equals to 5x, or 6 equals 5x. Then we divide both sides by 5, and that gives us x equal to 6 over 5. Lastly, we have negative 10, which gives negative 10 equal to 5x minus 3. Similarly, the 3 adds on the right side, so we get negative 7 equals 5x, and dividing both sides by 5 gives us x equals negative 7 over 5. Alright, this was just mainly computing. Now let's plot this. We just need any two coordinates to plot this, and the graph will be a straight line. Let's choose negative 2 and negative 13 as one pair, and 0 and negative 3 as the other. We plot this on our coordinate axes and make a line joining them. We are not given any specific length for the line, so we can make it as long as we want. Before moving on to more examples, I want to cover the concept of parallel and perpendicular lines. Two lines are parallel if they have the same slope. This also means that the two lines will never intersect. For example, if we have this line in white, then the yellow line is parallel to it as it has the same slope or same steepness. Furthermore, two lines are perpendicular if the slope of one of the lines is the negative reciprocal of the other. The graph for this can be shown as the line drawn in blue. It forms a 90-degree angle with the other line. Mathematically, if we have the slope of a line as m, then the slope of the parallel line will be m, while the slope for the perpendicular line will be negative 1 over m. Let's do a more advanced example now. We are given the equation 2y equals to 4x plus 6, and we are asked to find the slope, the y-intercept, and x-intercept, and then sketch the equation. We instantly see that this equation is provided to us in the slope-intercept form, but it is not exactly in the slope-intercept form, as the coefficient of y is not 1. This means we need to get rid of it first, so we can divide both sides of the equal sign by 2. This gives us y equals 2x plus 3. Now we can compare this to the general form to find the slope equal to 2 and the y-intercept as 3. The x-intercept refers to where the graph passes through the x-axis. At the x-axis, we have y equals to 0. So we input that into our equation. 0 equals to 2x plus 3. We take 3 to the other side of the equal sign, and it becomes negative, giving us negative 3 equals to 2x. Now, to find the value of x, we need to isolate it. So we divide both sides by 2. On the right side, 2 divided by 2 gives us 1, and we get our final answer, x equals to negative 3 over 2. This is our x-intercept. Finally, we move on to graphing it. First, we draw our x and y axes. Then we insert numbers onto both axes. We number the x-axis 1, 2, 3, 4, and negative 1, negative 2, negative 3, negative 4. Then the same for the y-axis 1, 2, 3, 4, and negative 1, negative 2, negative 3, and negative 4. We are just sketching the graph, so it does not need to be entirely accurate. An easy way to sketch linear equations is by plotting any 2 points on the line. Since we already found the x and y intercepts, we can sketch it using those 2 points. At the y-intercept, we have x equals to 0, so we get the point 0, 3. At the x-intercept, we have y equals to 0, and we get the point negative 3 over 2, 0. Connecting these 2 points and drawing a straight line gives us the graph of the equation. We can also confirm here that the slope is correct. A slope of 2 basically means that as the x value changes by positive 1, the y value changes by positive 2. So let's start from the point 0, 3. We move 1 point towards the right, and that should give us a change of 2 in the y values, which can be confirmed from the graph as we get 5. For a final example, let's try finding the equation of a line that passes through the point 2, 5 and has the slope of negative 1 over 2. Since we are given a point and the slope of the line, we can use the point-slope form to find the equation, which will be y minus 5 equals to negative 1 over 2 times x minus 2. Let's simplify this further. The left side can be written as is. For the right side, we multiply the negative 1 over 2 with both terms in the brackets. This gives us negative x over 2 plus 1. Now the minus 5 will go to the other side and add, giving us y equals to negative x over 2 plus 6. Just for more practice, let's graph this. We have a y-intercept of 6, so we mark that point on the graph. Then we have a slope of negative 1 over 2, which means for every increase in x, our y will increase by negative 1/2, or it decreases by 1/2. So when x equals 1, our y value equals 0.5 less than what it previously was. So it is 5.5. Now, we just draw a line connecting both points, and there's our graph. Before ending, let's just identify what the slopes for the parallel and perpendicular lines will be. Since a parallel line has the same slope, it will be negative 1 over 2. While for a perpendicular line, the slope will be the negative reciprocal for this, which gives us 2. I will draw some possible parallel and perpendicular lines just for show. The lines in yellow are lines parallel to the graph, and the ones in blue are perpendicular. To look for a specific line, we will need another point on that line as well.